The purpose of this video is to explain in a simple visual way how passive optical networks operate. We're accustomed to conventional networks, and it seems as though the optical network shouldn't work. To start this out, we're going to take a look at the conventional network first, get an idea how the demonstration works, and then we'll move on to the passive optical network. To start out with, we have a server shown in the drawing, and it's hooked up with the blue represents a copper connection to a router. The router has an optical transceiver, and the orange lines represent optical fiber. At some distance from the router, we have a switch, and we go back to copper lines that go out to 3 computers. Now we'll take a look at what it looks like as we put a packet through this network. Now we have a packet coming out of the server, and you can see we have the number 4 on that. It's destined to go to computer number 4 over on the right. Right now it's in the slow part of the network going to the router. This is may not be as fast as other parts of the system. As we get into the back plane of the router, we're traveling faster, and we'll be also going at a higher speed through the fiber interconnect. Now in the fiber, this is a pair of fibers, and one is going one direction, one going the other. And finally, you see that the packet ends up going through the switch and going right to the computer that it's designed for. So it goes back to there. I'm looking at packet number 1 going back to the server. Now I'm going to take a look at something a little different with the network. We're going to look at traffic coming from the computer towards the server. But in this case, it'll be simultaneous packets. Something will happen at the switch that they don't collide with each other. Now you see the 2 packets coming out at the same time, and they both have a 1 on them. They're heading for the server. Now, the packet up towards the top has stopped there. It's being buffered, and the other packet is going ahead of it. So there's been buffering that's taken place with simultaneous packets, so they don't collide. You'll see now that they're out on the fiber, and they're traveling in a fast part of the network, so you can see that how far apart they are. And then as they go through back into the router, you can see how they're now in the slower part of the network, and they're closer together. So that distance between them is an indication they don't travel at a higher speed through the fiber than they do through the copper. It's just a question of the density, how much data is traveling through there. So that's shown in how close the packets are together. So I'll just watch that again. You can see how there's a buffering taking place there in the switch, and that's how that network traffic is handled. And now we have an optical network shown here. This is a little bit different. What we'll have here is the server again, and the router, familiar from the conventional network drawing. But now we have another device called an optical line terminal. And basically, this may go right near where the router is, in sort of a central location. And it basically does something a little more than just being a media converter. It sets up the optical signals that are designed specifically for this PON network. And we travel out from that line terminal on a single fiber, and instead of having a distribution switch, we have an optical splitter, which is a totally passive device, and it splits the signal in that fiber 3 ways, well, many ways as set up on the network. Could be 32, 64, possibly even 128 ways. And then the individual fibers coming out of the splitter go to another device called the optical network terminal, which takes the fiber signal, converts it back into a conventional copper type signal,